So naming ionic compounds, oh, name each compound. Okay, there we go. So we do need to name these, which we'll do at the end. We'll come back at the end and do that. Okay, silver with a +1 charge. Do you remember or can you find what silver is as a chemical, as the name, the two letters
Yeah.
or the one letter?
Silver. Wait, silver is on the periodic table, right?
Yes, it's not a standard one though, so you may have to do a quick internet search to figure out what letters or letter it is.
All right. Okay, silver is Ag.
AG, AG. All right. And then chlorine. What do you think chlorine is? Or maybe we can look up here. Sometimes we've already. Cl is
Chlorine
-1.
is, yeah, it's Cl.
Yeah, so we can say the net charge here is +1, -1, and net charge is 0. All right. So now a bit more to do here. That's just the charges. Now we can go back and talk about the formulas in the name. So there are, this is lead to iodide. This is the correct name. I don't know how you would know that being this first time student, but we need to indicate in the formula, and maybe do it up here, that this is PbI2. Now you're really supposed to use subscripts, but that won't come out, and I guess in your when you copy and paste, so we'll do it that way. We'll use the underscore for that.
All right.
Now potassium and iodine, the chemical name is potassium iodide, and its chemical formula is just Ki. 1K and 1I.
Got it.
And you can see the formula here. For the next one, it's going to be calcium fluoride. I don't make the rules. And then you need two Cl, so I'm gonna put a little underscore 2 there to indicate that you need 2 of them.
Mm-hmm.
Okay. Let's go to the next one here. Lithium and oxygen. This is lithium, you guessed it, oxide. And then it's Li, 2 of them, 2 lithiums with one oxygen. Actually, the underscore might be weird. So let me remove it. And then the last one, I'm sorry, zinc. Sorry, not the last one. So this is zinc, zinc oxide. Sorry, oxide, and it is ZNO. ZNO.
Mm-hmm. So basically, it's just their names together, and then yeah.
The silver
So like silver
chloride.
chlorine. Sorry,
Chloride.
chloride.
Ides. They call them the ides. Fluorides, chlorides,
Yeah.
bromides. Um, I don't really know why this convention exists, but that is what it is. So, all right, that takes care of question 1. It's like a lot for question 1. All right. So could you go to your notes for this assignment and try to decide what the difference is between exothermic and endothermic? I'm going
Yeah,
to
I
just
can go
step away
check
for
in the
30
lesson.
seconds. Yeah, it's in their conservation energy. We'll talk about it together, but I'll be right back with you. All right, I am back. And the main difference between endothermic and exothermic. So I'll write that here. So exothermic is when energy is released.
Okay.
So you can think of the surrounding area getting warmer. Endothermic energy is it's the opposite. So I want to get the right word here, absorbed.
Gotcha.
Okay. So the surrounding area gets cooler. Sometimes it's really hard to know. Um, but like number three here, CSS gives off heat. That's clearly exothermic. Okay. Um, but um,
So,
but the other ones, I'm not sure if they're. Yeah, I'll just say that. So what kind of what's your feeling on this?
okay, for number two, I think it's exothermic as well because water evaporates when it's like really, really warm. Like, I
Okay.
mean,
So you think water evaporating is exothermic?
yes.
Okay. This is where I think I feel like and I don't really have a great, I'm not the expert. This is actually exothermic,
Oh.
which means the other one is endothermic.
So then number four is endothermic because it's making them cold.
Okay.
And the last one's exothermic.
Okay. Yeah. All right. So what I would do is go out to the internet and search for examples of exothermic and endothermic. Just look for those. I'll drop that in the chat in case you don't want to type it.
All right, thank you. All right, I found two examples. I just sent them in the chat.
Okay. Can you give me one more of each? I feel like that would be more what they want.
Oh yeah, sure. Let me find two more. Right here, two more examples.
Take a look here. So the issue with your examples, and this is, this is where you're basically giving me the same thing: burning of a sugar, burning of a candle. I mean, let's say burning of a piece of wood, right? Like, we want to not use the same thing. Like the endothermic, you did a better job melting solid salts, baking bread. The instructor will probably accept this, but like, we want to do more than the minimum. We want to maybe look for something else. But it's okay. I just want you to see that, like, it would be great if we were a little bit more, uh, not the right word is creative. We'll see. But
All right. I'm
yeah,
still waking up.
I get it. I get it. All right. So question 4.5. All right. What is the balanced equation for the reaction of N2 and H2 to form NH3? So it looks like this: N2 plus H2 to form NH3. All right. So on the left, on the left side of the equation, the left side of the equation are called the reactants. Okay. Um, on the right side, they're called the product.
Mm-hmm.
Okay. So the balanced equation means that you have the same number of nitrogens on the left as you do on the right. On the left, you have 2 nitrogens. On the right, you have 1 nitrogen. So that's out of balance. On the left, you have 2 hydrogens. On the right, you have 3 hydrogens. So without getting into like why, we're going to put a 2 in front of the NH3 and think of it as a 2 times, but really it's just a 2. So that means you have 2 nitrogens now. And really, it's like the hydrogens are in parentheses. So if you think back to your math class, 2 times 3 is 6. There's now 6 hydrogens there.
Okay.
That means you need 3 hydrogens there. And now the equation is balanced. Okay. So if you didn't understand that, hey, don't worry about that. You'll see it again in chemistry, and you'll do a lot more of them next year. Could you go to your lesson and tell me, put this in the chat so you can search for it, the types of chemical reactions there are? 1, 2, 3, 4 that they give you in this course. There's more than 4, but could you tell me the 4 types of chemical reactions that you see? They're in blue font.
All right. I will do that. In blue font, right?
Yes.
Okay, cool. So there is a synthesis, a synth. I'll just copy and paste them.
No, you gotta read synthesis reaction. That's fine.
Synthesis reaction, a decomposition reaction, a
Hang on,
single.
hold on. So let's just talk about one at a time. So you're looking at the synthesis reaction. You have 2 on the left that combine to 1 on the right.
Okay.
All right. Now look at a decomposition reaction. How does that compare to a synthesis reaction? Look at the A and B's in blue.
All right.
So in a synthesis, the 2 elements combine to make 1. What about what's going on in a decomposition?
In the decomposition, it's it's showing for A and B that they made them separate and then like they added them.
That's right. So they split apart and then they combine.
Yeah.
Okay. All right. Now single replacement is when you have two on the left and two on the right, but only one of them switch. Only one of them switch with the other ones. And then a double replacement, you can see the AX plus BY. You scroll down a little bit, turns into AY plus BX, basically both switch places. Um, so that just some background information. Now, if we look at your problem here, this is the first one. This is a synthesis reaction. It's where two elements combine into one.
I see. Right.
Okay. Question 5. Click on the separate water, blah, blah, blah. Okay. Follow the same steps to form bounce. What type of bounce construction? H2 from, okay. So it's a fancy way of saying, how do we go from H2O to H2 plus O2? And kind of like the last one, we know that, okay, there's two H's. That's what this subscript means. There's two H's, but there's only one O on the left, but on the right, there's two H's. That's good. Two O's so we're out of balance. So there's a two multiplier here, which makes four H's. So we need to put a two here in front of the H2 to get four H's. And then there's also two O's and two O's. All right, so this is the AB forms A plus B. Could you tell me which one that is from the notes?
That's decomposition.
Decomposition. Decomposition. There's a
Yeah.
slight difference. Composition, decomposition, right? Got it. Good.
I thought I said
Okay.
decomposition.
All right. Good job on that. So number 6 is the combust methane. And actually, this is the one that's not listed on there. Combustion. So CH4 breaks apart to form CO2 plus H2O. So a combustion reaction always produces water. I don't know why, but that's what it does. And maybe a good chemistry teacher will explain that. Seems like good chemistry teachers don't exist.
Oh
Uh,
wow.
yeah, I'm sure they're out there. It like they should be able to explain this. This should be like really exciting and like I don't know. I just it's okay. There is one C on the left and one C on the right. That's good. Okay. And then oh sorry, there's an O plus O2. I missed this part. And then there's O2 on the right, but there's also one here. So that's three O's and you've got two on the left. So that's out of balance. And then there's two hydrogens on the right and four on the left. So if I put a two here in front of the H2O, that gets us the four hydrogens. And then in terms of O's, there's two O's, and then there's two in the front times this O, so there's four O's, which means we're missing a two there. And now it's completely balanced. All right.
Mm-hmm.
So next one here is aluminum and oxygen to form Al2O3.
Yep.
All
Let me
right.
just
So the problem here is that that's out of balance. There's two aluminums on the right, but only one on the left. There's three oxygens on the right, but only two on the left. So if we balance out the oxygens, putting this two times in front, there's now six oxygens, which means you have to put a three here to get to six, and then two in front to get two aluminums there. This is an A plus B produces AB. Which reaction type is this?
De- decomposition. No, wait, no, 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 no,
It's
no, no.
it's yeah, two on the left becomes one on the right.
It, isn't it synthesis?
It is.
Yeah.
All right. All right. So um what is the name of each compound in this equation? So I want you to look up on the internet HCl and ZnCl2, ZnCl2, and put those in the chat, please.
You want me to search up the names, right?
Yes, yes. Go ahead and just put those in the chat or in the search for those and see if you can get the names.
Okay. So Zn is zinc.
Zinc, yeah. But you want to type in the ZnCl2 and the HCl.
Yeah, I'm about to go do that.
Okay.
H. That's hydrogen.
No. Together. We already know that it's hydrogen and chlorine. What's the name when they're together?
Like all of it. The
Yes.
ZnCl, that thing.
Yes.
It just keeps giving me hydrogen. Now I'm gonna type in the ZnCl2 and maybe something else will pop up. And that's aluminum. Holmium? I don't know.
So the search would be something like HCl name chemistry. That's your search. ZN ZnCl2 name chemistry. So I'm putting those in the chat there.
Alright, let's go see if Google will give me an answer because the periodic table doesn't want to cooperate with me.
Well, the compounds are not going to be in the periodic table. They're individually there.
Yeah. It says for ZnCl2, that's zinc chloride.
Okay, go ahead and put that in the chat, please.
Right. Right, and now HCl. That is hydrogen chloride.
All right, could you put that in the chat, please?
Yes, there you go. I sent them both in chat.
Yes, thank you. All right. So now in terms of the type of reaction is this, it's an A plus BX produces AX plus B. Could you look and see what that is in the notes?
Yes, I can. That's a single replacement, right?
It is a single replacement, yeah. Oh, I should have asked this earlier. Is there any questions? I don't think there have been where we need to put a link in. Maybe this one for the endothermic and exothermic.
Oh
Um,
yeah, I think I had the oh dang it,
if you have
I
that,
closed the link.
if maybe look in
Oh,
your history, if you can. If you
I
can't, that's
found it.
okay. All right, we can add that in.
It just sent the link.
Thought code. That's probably not the best. Let's not use that one. I like these. I mean, that's what we want, but that's not what your instructor wants. We want like a science-y, uh,
That's when I
link.
found all of those examples
I
though.
know. Well, so the the way to do it is to use those, but then you also need to go find some sort of a more like there. See, this article, this is fine. Like this one is totally fine. It's just that the perception is wrong. It's written by a PhD person. Uh, like there's nothing weird about it. But yeah, I mean, they're just your instructor. I don't know. We'll put it in. Some of these things get such a bad rap. Okay. Um, is the equation balanced? Show your work. So this is where I really want to use a table. They use the table method in but we'll do it differently. So before there's a zinc, H, and Cl. And actually let me go grab the equation one more time here. That will help. All right. Okay. How many zincs do you see before in the left side? I should call it reactants. How many zincs do you see on the left here? It's not a trick question. How many zincs do you see? Maybe you're muted.
Oh no, I'm so sorry. I couldn't hear what you said because
That's
someone
okay.
is doing gardening outside and it's so loud.
Yeah, they got to trim those trees early.
Yeah, what did you say?
How many zincs do you see here on the left side, on the reactant side?
Oh, just one?
Okay. Now, how many H's are there? And you do have to account for that two in front.
So, three?
Two.
Oh, dang it.
There's one sort of H, but you multiply it by two. How many CLs are there?
One.
But then you have to multiply it by two.
So two.
Yes. Okay. Now on the product side, um, on the product side, how many zincs do you see on the right here? Not a trick question. How many zincs do you see?
There's
Maybe
one.
one. Now the CLs, there's two, it means there's two CLs.
So it's two again.
How many hydrogens do you see on the right?
Two.
Are these numbers the same?
Yes.
Okay, so yes, it's balanced. Yeah. So we have to do the same thing for this one now. Rinse and repeat here. FeS, you have to look up. HCl, H2S, and FeCl2. You'll have to look up for the names for each of those, please.
All right. Let me go search them up. Okay, the first one is iron sulfide. I'll
You'll
just type
please
it.
go ahead and put that in the chat, please.
I'll just type them all in and then I'll just send them to you.
Sounds good.
Alright, that's one. Alright, I sent all of the names in the chat.
Okay, I will take a look.
I double checked to make sure I think the names are correct.
Yeah, so the second one has to be capitalized.
Uh-huh.
It's like a proper noun. We're getting into English stuff now. I don't care. But some of these instructors, they're really like it's really a big deal.
Yeah, like my English teacher who still doesn't want to give me a grade for that one essay thing that we did.
Wow, wow. Yeah, I mean, I think you may have to, in that case, either, have your parents communicate with them or uh just maybe even you yourself just set up a time to talk to them and um
Yeah, I will tell you everything after the next time, like 10 minutes later when we meet up again.
sure.
So, because in my opinion, I think it's funny why she's still so picky about it, but at the same time, I'm frustrated.
Yeah, and I mean, good news is we've been able to move on. We've been able to keep doing assignments. Bad news is at some point
Exactly.
it's got to be dealt with. I'm happy to communicate with your parents if needed about this. It's
I'll let my
sometimes,
mom know. She'll talk with the teacher.
yeah.
If not, I will
Um,
talk with her.
all right, so this is an AY produces or BX. What kind of reaction is this?
Um, oh, I know this one. Wait, where? But I don't remember the name. Double replacement?
Is double replacement? Yeah. Okay, let me grab the equation. All right. So FeSHCl. Okay. I want you to tell me how many Fe's there are before and after, please. Or reactants and products. So the left side and then the right side.
I gotta go search up their names again, right?
No, no, no. You just have to see how many are on the left, how many are on the right.
Okay, so there is one FE on the left.
Okay.
There's For S, there's also one.
Let's do, so try, okay, yeah, that's fine. Yeah, we can do that. For S, there's also one. All right. And H,
H is also one. And then CI is also one.
CL, CL.
CL, sorry. I think
Okay.
what you wanted to say is like, let's just do one. You look at like for FE, one on for the left, and you say the other one for the right, instead of having to go.
That's a, yeah, even if that was my intent, learning is fluid. You can do, there's no like, it has to be this way. So, um, all right, let's look at the right now. How many FEs do you see?
A one.
Okay. At S, how many S's do you see?
Do I have to multiply by that two that's right next to H?
The two only applies to the H,
All
unless
right,
it's in
cool.
front of
So
both of them.
one S.
Okay, how many H's?
Two,
How many CLs?
two.
Okay, so we have a problem. It's not balanced currently. So we should say that, not balanced. Okay, and then we should balance it. So to balance it, if you put a two in front of the HCl, how many how many H's do you have now to start? And how many CLs do you have now to start on the left side? Look at this line now. How many H's, how many CLs?
I'm sorry, can you repeat that one more time?
Yeah, I'm just trying to ask you how many H's you have now?
Two,
Okay. How many CLs do you have to
two.
start? Yeah, now it's balanced.
Now it's balanced.
Yeah. And we don't need to get into like why or there's all these other things, but there it is. All right. Okay, let's see how much more fun they have for you here. All right. I'm in the wrong lesson. All right. Wait, there's
Uh,
more. All right. Okay. All right, look back at the collision theory of chemical reactions applet. Click on the reset to high energy initial setting. Okay. Um, can't believe they're using Java. I'm just looking at trying to figure out how to get this to work. Um, okay, here we go. So there is I think it's easier if we just watch it individually in our own windows. So let me put this in the chat here. It's a 1 minute video. If you could watch that, I'll do the same.
the 1 minute video that's the one that's right after under the balance like
Yeah, I put a link to it in the chat. It's
okay,
the
cool. All right, cool. I'll watch it. I'm gonna just mute myself and watch it really quickly. when I watched the video, it basically just shows how the chemicals, they were like, some of them were together and then they just split and then, I don't know, combined it with the other ones.
Okay, yeah, so like on the second one though, they don't break apart.
Wait, what? I'm sorry.
In the second that there was reset to high energy, reset to low energy.
Yeah. Uh,
So we need to put that into words here.
all right.
So let's go back to so in the first one, they broke apart. We'll say first, they broke apart and combine. Um, Second, they move much slower, fast, move slower, did not break apart. So I guess we need I know this is least fun. You might need to watch it twice. Um,
All right.
but we need a sentence or two that says these things in there.
Let me just rewatch this video really quickly.
Yeah.
All right. So after, so the difference between the two stimulations, like the first one, you saw one connected so fast, but the second one, when they had to do it again, they didn't connect at all. They just
That's
kept
right.
avoiding each other.
Yeah, so that's the major difference. You want to say that I mean you're actually kind of saying you're basically saying the same thing in the first and the second. In the second, they did not break apart, did not combine, basically.
All right. Um, chemicals are so interesting. Anyway, um,
Okay, why don't we pause here? We'll pick up here um the next the rest of these are going to be questions we're gonna have to look on the internet. I can provide some help. Um, but we'll need to provide sources for these.
all right.
Okay, so let's pause here and we'll pick up in about 10 minutes. Okay.
Okay.
All right. Bye.
Bye.